Alright, I'm picking up from the last one, so this will be part 2. So we just concluded that every permutation on a 3 by 3 by 3 is even. And so something like this, a single 2-cycle, which we can see on a 2 by 2 puzzle or on a 4 by 4, something like this is impossible. You can't get it. So another impossible is also something like, UF goes to UR and back again. This is impossible also. It's a single 2-cycle. But, something like UFL, UFR, and back again, and UFR, UR, back again. This together is possible. Think about why. Why is the combination possible? Well, there's a 2-cycle and a 2-cycle. This is one swap. It's a literal swap. This is one swap. 1 plus 1. 2 swaps. This is even. The cube, the 3 by 3 by 3, has even permutations. I don't have one. I should have had one available to show you. But if you're really interested, I can go find one. Maybe I will. No, I couldn't find one. But I've seen one somewhere. I just couldn't find it in my resources, my references. So in any case, this would be possible because it's even, right? Whereas individually, neither of these things are possible on the 3 by 3. So we've seen cases where the 2 corners are possible in other puzzles. You can have something like this on puzzles as well. Let's look at why other puzzles have different possibilities. Let's start with just the 2 by 2. In the last video, we looked at the cycle structure of a face move. We'll do the same thing here again. So if I look at F on a 2 by 2 by 2, what does that do? Well, there's only 4 corners. So it's up, front, left, goes up, front, right, goes down, front, right, goes down, front, left, and back again. That's a 4-cycle, which is equivalent to 3 swaps, even though we don't literally do the 3 swaps, is equivalent to it, which is an odd permutation. Now, if I do something like F and then R on a 2 by 2 by 2, that's an odd permutation and an odd permutation. That's an even permutation. And we can even check this. It's a good little experiment. If we do F, it's a little hard to do cycle structure on 2 by 2 because there's no middles. So as soon as you start changing things around, it's a little hard to tell where you were going. So you might want to do this in pieces. Notice that, well, you may not want to do this at all. But we'll run through it. So maybe I'll start on down, front, left. So if I do F and R, see where that corner went? It went up, front, left. Where did up, front, left go? Watch it. It goes up, back, left. I keep redoing it because it's really easy to lose track of what color is what. So the piece that used to be up, back, left ends up being down, oops, right, sorry, it's right, not left. Down, back, right. And then think about this piece, which was down, back, right. It comes down, front, right. Right. What piece used to be here? Well, it used to be this piece. Right. So it's right there. So down front right goes to down front left. 1, 2, 3, 4, 5. That makes sense, right? This corner is twisted. It doesn't actually move, right? This is the yellow, green, red corner. Watch that corner. It's right back to where it started. It's a 5 cycle, just like we had on the 3 by 3 by 3. So, but a 5 cycle is the equivalent of 4 swaps, which is even, just like we thought. Right? So sometimes you'll get even permutations on a 2 by 2 by 2, and sometimes you'll get odd permutations. For example, F, R, U, well, that's odd plus odd plus odd equals odd. So this would be an odd permutation. And something worth thinking about, so that state I showed you, where I showed you that there were 2 corners, this one right here, these 2 corners need to be swapped. This is an odd permutation. Well, how do I fix that? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 15 face turns. 15 face turns. Each is an odd permutation, meaning each face turn is equivalent to an odd number of swaps. 15 odds, that is, if you took 15 odd numbers and you added them up, well, that would be odd. And the way to think about that is that every time you add 2 odds, you get an even. So you can make 7 pairs here, 14, of even numbers plus 1 more odd. So it's not surprising that it takes an odd number of face turns to solve something that is an odd permutation. So what we have going back and forth here is this kind of abstract idea of parity, cycle structure, being reflected on these puzzles. Another example, this used to be called the magic domino. It was made out of dominoes, or had domino markings. It's now the 3 by 3 by 2, depending on how you denote it. And there's a couple things going on here, right? It's like a Rubik's Cube that lost the middle, right? So it's a little like, so kind of like this. It doesn't have a middle layer. So if we look at the parity on this puzzle, if I look at, say, the up face, the parity of U on the 3 by 3 by 2 will be even, just like the ordinary cube, because there are 4 corners, the 4 cycle, 4 edges, the 4 cycle. But on what amounts to the front face, I can't do a quarter turn. It's not permissible. So I have to do a double turn. That's all that's allowable. Well, what's the cycle structure of this double turn, this f squared? Well, the up front left piece, that's over here now. So that's down front right. And the down front right piece is now up here. You can just see these two. They just swap places. So that's a 2 cycle. Same with those 2 corners. Up, front, right, goes down, front, left. And then there's only 2 edges. So, whoops, I'm sorry. Up, front, goes down, front. 2 cycle, 2 cycle, 2 cycle. 2 cycle, 2 cycle, 2 cycle. So that is a literal single swap. So 1 plus 1 plus 1 equals 3. Aren't you glad you learned that? Which is an odd number. All right? So the side faces have odd permutation, whereas the top and the bottom have even permutation. So when you combine them, you can get odd permutations. Here's an example. If I do f squared u squared 3 times, if I go back to the ordinary Rubik's Cube, I do f squared u squared f squared u squared f squared u squared, I'll end up with a pair of 2 cycles, which is legit. This is one swap, this is a swap, 2 swaps is even. If I try that on this puzzle, I go f squared u squared f squared u squared f squared u squared. Well, there aren't any edges here to be swapped. I just have that 1. Every time I'm doing one of these, let's write this out. This is f squared u squared f squared u squared f squared u squared. The u squareds are even, and the f squareds are odd, as we saw above. So if you add an odd and an even, it's odd. Odd and an even is odd. Odd and an even is odd. So this is odd. This is an odd. This is an odd. 3 odds is odd. We have an odd. Whoops. We have an odd permutation, which we do. Right? It amounts to up right goes to up left and back again. So sometimes these things can happen and sometimes they won't. It just depends on what parities are possible on a given puzzle. Alright, this will be the end of the second part, and then I'll do some other examples in the third part.